So input minus output 1, that should be equal to your mass of A in output 2. So what we are doing is like we are just calculating how much A goes in, how much A comes out in one stream, and how much A comes out in output stream 2. So, so if this is 1 kg, this is 0.25 kg, so this should be obviously 0.75 kg of A. So these are some understanding you should know. Another one you should know is like how to perform a, so this what we performed is like a component mass balance. So we have one stream, we call it as input stream, that has some component A. So we perform the mass balance on this particular component. So that's why we call it as component balance. Or you can perform a total balance, or sometimes we can call it as flow balance. You have some system, say something is going say 10 kg per hour and say 2 kg per hour. So this is total flow rate. So 2 kgs of some product comes out in this stream in 1 hour, and then so another one is this should be how many kilograms per hour. So this is total balance. So input is equal to output 1 plus output 2, that should be equal to 10, that's equal to 2 plus output 2, that should be equal to 8 kg per hour. So this should be 8 kilograms per hour. So these are the basic things you should remember when we talk about mass balance. So coming back to this problem, I don't know where I wrote, it's here. So I'm going to read the problem for you. So we are going to perform an ethanol distillation using a distillation unit. I'm sure you all know how the distillation works. So if you have two fluid, one with low boiling point and another one with high boiling point, so when you heat it at some temperature, the one with the low boiling point, it's going to become a vapor, and then you can collect at the top, and then the one at the with the low boiling point, you can collect them at the bottom. Normally this will be liquid and this will be gas, which we can condense to make it back into liquid state. So these are the basic things, basic idea about the distillation, how distillation works. So I'm going to read, this is very important problem in bioprocess engineering, so I will read the problem for you. So liquid from a brewery fermenter can be considered to contain 10% ethanol. So the fermentation broth contains 10% ethanol and 90% water, and this fermentation product is pumped at a rate of 50 kilograms per hour to a distillation column. So you have a distillation column, we are pumping some fluid that contains 10% ethanol and 90% water at a rate of 10 kilograms per hour to a distillation column at the factory site. So under normal operating conditions or current operating conditions, a distillate of a 45% ethanol and then 55% of water is produced. So something which comes at the top, so that one contains 45% ethanol and 55% water from the top of the column at a rate of 1/10 of the feed. So what does that mean? If you are pumping something inside at 50,000 kilograms per hour, the flow rate at the top of your column is exactly 1/10 of your feed flow rate. So it should be 1/10 multiplied by 50,000 kilograms per hour. That's the flow rate in the top of your distillation unit. So what we need to calculate is what's the composition of the waste bottoms from the still. So let's call this one as bottom, where we collect some liquid. So I asked what's the percentage of ethanol in the bottoms and what's the rate of alcohol loss in the bottom. So all you need to calculate is so the percentage of your ethanol and percentage of your water. So that's the thing you have to calculate. And you also need to say what's the rate of alcohol loss. So how much So how many alcohol you lose in the bottom product. Yeah, so you know how many, what's the mass of alcohol that goes inside, and you know how much, what's the mass of alcohol that goes in the top. So all you need to know is how much you lose in the bottom. So you need to know the mass of alcohol that comes in the bottom. So anyway, if you know the composition of ethanol and water in the bottom, obviously you can calculate the mass of ethanol that you lose in the bottom of your distillation tower. So try to read a bit about distillation. For this, for your module, distillation is a very complex topic and you can have a separate module on distillation units. But all you need to know is like there is a distillation unit which we really need to produce ethanol from the brewery plant. Yeah, so that's why we are studying this, and we know some mass goes inside, some mass comes out. So we are going to perform a mass balance calculation on this particular distillation unit. So if you need to solve the problem, all we need to know, we should know how to draw diagrams. Yeah? So let's call this distillation unit, and then if you read the problem, some stream goes inside. So we are pumping a stream to the ethanol distillation unit. So we are pumping some stream. So let's call it as feed. Let's put it as F, and we are pumping this at a rate of 50,000 kilograms per hour. So this is given in the problem, and then something comes at the top, let's call it as T. Something comes in the bottom, let's call it as B. So to perform mass balance, all you need to know is how to draw diagrams like this, and you should know to draw the arrows. So how many input streams, how many output streams, and then you have to give the notations like F for feed, T for top, B for bottom. So, and in the top, what's the value? I already gave the composition, which is 45% ethanol, and then 55% water. So 55% water. I'm going to write WAT, water. Yeah? And then your feed contains 10% ethanol and 90% water. And then your bottom product, what it contains. Okay, we don't have the information, so we need to find the flow rate, and we also need to find the composition. So that's the question. And in the top, we know the flow rate. I already mentioned, it's like in the top you get 1/10 of your feed, so that comes to the top. So your top flow rate, mass flow rate should be, if the input mass flow rate is 500 kilograms per hour, so every 1 hour we are supplying 50,000 kilograms of some mass that contains 10% ethanol, 90% water. So this is your some fluid stream that goes into the distillation unit. In the top, the flow rate, mass flow rate will be 1/10 multiplied by 50,000. So that's the value I already gave you in the question. So this should be equal to 5,000 kilogram per hour. You must pay attention to the units. So now we can calculate the flow rate of your bottom. I said to you, so input must be equal to output. So we know 50,000. So we can call it as a flow balance. Flow balance means flow rate in, that should be equal to flow rate out. So flow in should be equal to flow out. Or if you want, you can call total flow in, that should be equal to total flow out. So total flow in is 50,000 kilograms per hour, and then that should be equal to flow in the top plus flow in the bottom. So in the top we know how much value, 5,000 kilograms per hour. So therefore the flow rate in the bottom should be equal to 50,000 kilograms per hour minus 5,000 kilograms per hour. That should be equal to 45,000 kilograms per hour. So if you go back here, your flow rate that comes in the bottom is equal to 45,000 kilograms per hour. So we calculated one unknown parameter, so now we need to calculate your composition in the bottom. So how to do that, you should know how to perform component balance, individual component balance. I already showed you how to perform or how to calculate the mass flow rate of individual components. So if you take here, you have 50,000 kilograms per hour, and 10% of that is your ethanol. So we are going to perform in component balance. Component mass balance, to be precise. So what, for the moment we take ethanol. So how much mass of ethanol goes in and how much mass of ethanol comes out, so that we can calculate very easily. So if you go back to this same figure again, so 50,000 kilograms per hour and 10% of that is your ethanol flow rate. So mass of ethanol in should be equal to 50,000 kilograms per hour multiplied by 10 by 100. So that should be equal to 5,000 kilograms per hour of ethanol and we can also, what else to do, we can also calculate the mass of water in the feed stream. We know 90% of your feed stream contains water. So mass of water in the feed stream is equal to 50,000 kilograms per hour, that's your total flow rate, multiplied by 90 by 100. So 90% of this flow rate contains your water. So 0 0 gets cancelled, 5 9s are 45, 3 zeros. So 45,000 kilograms per hour of water goes in. So we can write those values here. So let's change the color. So what we found, so whatever I'm writing blue, so those are the parameters we found. So 10% ethanol, that's equal to 5,000 kg per hour ethanol, and then 90% of water, so that is equal to 45,000 kg per hour, that's your water. And then we can perform the same for the top. I already gave in the top product contains 45% ethanol here and then 55% water. So we can do the same calculations like before. So 45% of 5,000 kilograms per hour, so that will be like for ethanol in the top, 45 by 100 multiplied by 5,000, that should be equal to 25, 2250 kilograms per hour. And we can do the same for water. So how much water? 55% of 5,000, so that will be the mass of water in the top. 55 by 100 multiplied by 5,000, 5,000, 0 0 cancels, 0 5 5 are 25, so then 25 plus 2, 2750 kilograms per hour. So now we know how much mass of ethanol goes in, and then how much what's the mass of ethanol that comes in the top, and what's the mass of water that comes in the top. So now we can calculate the mass of ethanol that comes in the bottom, and the mass of water that comes in the bottom. It's really easy. So what we are going to do, so let's say water in equal to water out. So how much mass of water goes in? So and and we have so F, and we know like top plus bottom for water. Now we are going to do everything for water. So so what's the mass of water that goes in? We just now we calculated 45,000 kilograms per hour. How much in the top? We calculated just now 2750 kilogram per hour plus. So what's the B value in the bottom? So that's what we need to calculate. So this is for water, don't forget that. So it will be equal to mass flow rate of water in bottom should be equal to 45,000 minus 2750. So that should be equal to 42250 kilograms per hour. So for these calculations you don't even need a calculator. It's very simple, and you can do the same way. We can calculate ethanol. So ethanol in equal to ethanol in top plus ethanol in bottom. So these are like a individual mass balance or component mass balance. So what we did here is for water. Water is your component. Now we are performing ethanol mass balance. So ethanol in, we already know how much is that, 95% of 50,000 kilograms per hour. So that's 45,000 kg per hour. That's equal to ethanol in top. How much is that? Ethanol in top 45%. Okay, so you already calculated 2250, I think. Yes, 2250 kilograms per hour. That's in top. Yes, plus bottom ethanol. So this should be, so ethanol mass flow rate in bottom or B should be equal to 45,000 minus 2250 kilograms per hour. So that should be equal to there is some mistake. So 45 multiplied by 5,000, that should be equal to 2250 kilograms of ethanol in the top. No, this is water content. Your ethanol content is 5,000, just 5,000. So it's only 5,000. So that's equal to 5,000 minus 2250. This should be equal to 2750 kilograms per hour. So what I asked is like how much, what's the mass of ethanol that you lose in the bottom. So it's equal to 2750 kg per hour. And I also asked you to calculate in terms of weight percentage. So weight percentage of your individual components in the bottom. So that's very easy. So you know ethanol mass is equal to 2750 kilograms per hour, and then we know a weight of mass of water, that's equal to 42250 kg per hour. So all you need is to take the total, so total will be, so I asked you weight fraction percentage, you have to give in terms of percentage weight fraction. So what is this percentage weight fraction? Is the same which is given in your question. So I said you have 50,000 kilograms per hour. So 10 weight percentage is ethanol, 90 weight percentage is water. So now we know in the bottom you are going to, the flow rate is 45,000 kilograms per hour. So I asked you the same percentage of ethanol, percentage of water. So we already know the kilograms, so we need to convert it into percentage of ethanol and water. So how to convert it? So percentage weight fraction, how to do that? So if you know the individual mass, you take a sum and then you take the fraction. So percentage weight of ethanol 2750 by 45,000. So this should be equal to multiplied by 100 because we are talking in percentage. So I'm going to use the calculator. 2750 this should be approximately equal to 6.1%, and then percentage weight of water, so that's nothing but 42250 by 45,000. So that will be equal to multiplied by 100. So we are talking in percentage, so that's why we are multiplying by 100. So I think we solved the whole problem. Yeah? So we answered all the we calculated all the unknown parameters. So if you go back to here, so the answer is like percentage ethanol. So our answer says 6.1% ethanol, and then 93.89 percentage of water. You have to practice, if not it's going to be very difficult in the final exam. So try to solve the same problem without looking into the video. Try to listen to the video and then try to solve it by yourself. So I think this is a very good problem to understand how to perform a total mass balance, how to perform individual component mass balance. So the whole idea, you have to understand how to perform total mass balance and how to perform individual mass balance. So that's more than enough. If you know how to do this and how to calculate these unknown parameters, then that which means you solved 90% of your mass balance problem. And normally the easiest way to deal with or to solve a mass balance problem is, first you must believe that I can solve this question. You have to read the question at least 5 to 6 times, and then try to understand what are the parameters you have, and then try to make a figure out of that, and then try to draw some flow diagram. So that will help you to know how many stream that goes in, which is normally your input stream, and how many stream that comes out. In the exam I might ask a distillation column with more than one input stream, so you must able to calculate it. So I covered this part. I think Jack covered the azeotropic distillation that contains one more input stream. So I think both are more than enough to understand how to perform the mass balance on a distillation unit. And all you need, and you should be very good in labeling, like F for feed, T for top, B for bottom, and then you have to perform. So using these simple notations, you can perform the total balance, like F is equal to T plus B. So feed is equal to top plus bottom. So top and bottom are your output streams, F is your input stream, and then you have to calculate the percentage in each of your stream, percentage of each component in input stream and percentage of each component in your output streams. So it's such a straightforward problem, yeah. So and then I'm going to stop recording this one. I know I'm going to upload into 3 parts the this particular tutorial, because I had few doubts when I was explaining to you. So I stopped one time myself, and then the second time I started to solve, and then for some reason my TV went on with for so I have to stop the recording, and then I continued the same problem. So you will have 3 videos for this one simple problem, which is your distillation unit. So the key message is not the distillation. So you, we solve this problem to so that you will understand how to draw a flow chart, and how to name your streams, and you should count the number of streams that goes inside. You can count the number of streams that comes out. For distillation unit, you have one input stream and you have two output streams, and then you can have more than one input stream, yeah. So like if we take azeotropic distillation, we will add one more component, so that you can get 100% ethanol. So these are some things you must remember. So whenever you see a mass balance problem, your mind should think immediately how it's like how many input streams that goes in, how many components are involved in the whole system. So in this case, you have one input stream, two output stream, you have two components, one is ethanol, one is water. So these are the things you must remember in your mind, and moreover you should believe that you can solve the problem, no matter you have an engineering background or no. You must have that 100% confidence that I can solve the problems. It's really easy, like anybody can tell, you have 1 kg, and 10 percentage of 1 kg is what? So it's 0.1 kgs. So and you are applying the same common sense to mass balance. In fact, mass balance is like the only theory you have to remember is like mass cannot be destroyed and mass is conserved, which means mass is conserved. And 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 you apply that theory, and then you apply some common sense, like, okay, I have some input stream. Somebody says 10 percentage of that input stream contains ethanol, so you can calculate that if your input stream is 10 kg per hour, 10 percentage of that if is ethanol, it means it will be equal to 0.1 kg per hour, and then which means the remaining 0.9 kg of that stream is going to be water. So these are the things that should come into mind, and you should be really bold enough to solve the problem. So I will stop the recording now. Thank you. Thanks for listening.